Good morning, everybody. Okay, I hope everybody is doing fine. Today I am going to explain you about the single phase transformer. Okay, so this comes under the module number 3. Okay, today we will discuss about the single phase transformer. So before going into this module, first let us see what is a transformer. So why it is very important in an electrical engineering. Okay, so the three main aspects of electrical engineering are generation, transmission, and distribution. Okay, generation, usually the electricity will be generated at the generating station. Okay, these generating stations will be situated at a remote place, that will be very far from the cities. Okay, it will be situated at a remote place. Okay, so the generated electricity has to be brought to the distribution system. So that distribution station, from the distribution station, the electricity will be supplied to the home application and for industrial application. So we are going to bring the generated electricity from generating station to the distribution station through the transmission lines, and from the distribution station, okay, from the distribution substation, okay, the electricity will be supplied to all the for various areas in that city and for industrial applications also. Okay, usually the electricity will be generated in the generating stations at 11 kilowatts. Okay, so it will be generated at 11 kilowatts only. Okay, so if we are transmitting the voltage at 11 kilovolts from generating station to distribution station, then the power losses will be more. Okay, so we have to transmit the electricity uh, at higher voltage, like 66 kilovolts, 110 kilovolts, 130 kilovolts, sorry, 132 kilovolts, 220 kilovolts, and 400 kilovolts. If we increase the level of voltage for transmission, then the power loss will get reduced. So for this purpose, to increase the voltage level from 11 kilovolts to 66 or 400 kilovolts, we are going to use a transformer called as step up transformer. Okay, so again, at the receiving end, that is at a distribution substation, we are going to step down that voltage from higher voltage to 11 kilovolts. The higher voltage may be 66 kilovolts, 110 kilovolts, 132 kilovolts. So these voltage has to be stepped down to 11 kilovolts. Okay, so this has to be done using a step down transformer. Okay, step down transformer is a transformer which reduces the level of voltage from higher voltage to lower voltage. Again, here also we are using a step down transformer. So further, the, while distributing the electricity for the homes at various localities and for industrial applications, so again we are going to reduce the 11 kilovolts to 415 volts. Okay, so for this purpose also we are going to use the step down transformer. Okay, so step up transformer and step down transformer are very extensively used in the power systems. So it's a very important device in electrical engineering. So along with this, small transformers also will be used in electronic applications. We are going to use small transformers for electronic applications also. Okay, so this is the diagram of a power transformer. So power transformer we are going to use for high power applications, and the voltage level of the power transformer will be very high. Okay, and this one you can see the distribution transformer. So usually this transformer we are going to use for 11 kilovolts. To reduce from 11 kilovolts to 415 volts, we are going to use the distribution transformer. Okay, so this transformer will be there in each and every area in the city. Okay, so from this transformer itself, the electricity will be given to every homes. Now let us see the construction of the transformer. Okay, so transformer, we will see what the transformer is made up of. The main parts of electrical parts of transformers are basically main parts are the magnetic core and windings. Okay, so the core of the transformer is in the shape of either it may be a square or it may be a rectangle. So it is shown as shown in the figure. So you can see there is a square here. So the top and bottom part, so that is the horizontal part, is called as yoke, and the vertical part is known as the limb. Okay, so the horizontal part is known as yoke, top and bottom, and side, that is the vertical portion, is called as the limb. Okay, so the core is usually made up of silicon steel laminations. So we are going, the transformer core is made up of laminations to reduce the eddy current losses. So why the silicon steel is chosen for this application is it is having a very it is having a advantages over the other materials. So the advantages are it's having a very high resistivity, okay, and it's having a low hysteresis power loss, and it is having a high permeability. Okay? So these are the advantages of the silicon steel laminations. Okay, each laminations is coated with varnish to provide the insulation between the laminations. Okay, so we have to place a insulating material between each of the laminations. Okay, so the core of the transformer is not made up of a solid. Okay, it is not made up of a solid. Instead of that, it is made up of a laminations. Laminations means one layer of lamination will be there, a small thickness of lamination will be there, next to that a insulation will be placed, so next to that again a lamination will be there, again next to that a insulation will be there. Okay, usually the thickness of the lamination will be 4 millimeters or less than that. Okay, so this is related to the transformer core. Okay, so one more thing is very important part is winding. Okay, so winding usually will be having two windings, one is primary winding and one more is secondary winding. Okay, the winding which is given to the supply is called primary winding, and the winding which is given to the load, connected to the load, is called as the secondary winding. Okay, so usually this winding material will be made up of a very good conductors like copper and aluminum. Okay, so for large transformers usually we'll be using oil cooling.